Well, it's like I always say, Your Majesty. Children got to be free to lead their own lives.
We want to test whether the slope is 0, and I'll explain why, but I have hiccups today, so forgive me. Yeah, they're the painful kind. So we're going to measure whether eating fish oil or drinking it or whatever you do with it is going to affect your IQ, because I've read that that does. If the slope is like this, then as you have more fish oil, you raise your IQ. If the slope is like this, more fish oil lowers your IQ. On the other hand, if the slope is 0, which is what the null hypothesis says, then changing how much fish oil you have does not change what your IQ is predicted to be. So this is where fish oil does not affect IQ. The null we have there is testing. Okay, I think hiccups are gone. It's testing whether fish oil has an effect or not. The null hypothesis saying here with a slope of 0, different levels of fish oil, same of IQ. So no, there's no effect. Whereas the alternative says yes, there is an effect. Remember, our goal here is to be able to do predictions. So we are trying to see whether fish oil is helpful to predict IQ. Eventually, we're going to get to where we have lots of variables, and we're going to see whether some of those variables should be in our model or not. Do they help or not? Which ones help us to do a prediction for the y variable? And so that's where this comes. Now I'm waterlogged and I have hiccups. When we look at the actual data, just by luck, the slope will be a little bit positive or a little bit negative based off randomly what data we get. So we're not going to get a slope of 0 from our data. But when we look at the regression line, the question is whether the error in this regression line could allow for it to be flat. So could a flat line be reasonable based off the strength of the slope and how much error we got in there? Notice that we're never going to prove the null hypothesis true. We can't ever say that we have shown that there is no relationship between these two variables, because a very slight relationship, maybe if you had more data, then you could show that that relationship really existed. But if the slope is strong enough, meaning steep enough relative to the error, then you could say, yes, we have shown that this variable helps predict. So we can use the alternative if we have a small p-value to say, yes, there's a relationship. If there's a big p-value, then what we can say is, look, our data can't show that there is a relationship between these two. Wait. I think all these hiccup cures are just placebo. How did we put a man on the moon and we can't cure hiccups? So, to test whether there is a relationship, we're going to look at the slope we get from the data relative to how much error there is in the slope. And you don't need to know this equation. The computer's going to do it for us automatically and get us a p-value. Small p-value, we say, yes, this variable helps us to predict whatever our y variable is.